And how do you pronounce your last name?
Rau.
Rao. Okay. Okay, I'm just going to start. The rest will log in one by one. I'm recording now. Okay. So good morning, everyone, and welcome back to our webinar series. It's good to have you back today. Today will be our first webinar of 2 webinars about machine learning. I'm very happy to have Laurence Rau with us today. He's our expert on machine learning, and he will fill you in on how to prepare the data. Before we start, I would like to make a few announcements. So as you, when you log in, you will see a chat box and a question and answer box. The chat box can be used to reach out to the panelists, to the 4 of us, in case you have any technical issues or questions about the coordination of the webinar series. The question and answer box can be used during the whole session for your questions. We might interrupt Laurence from time to time to take some questions. If not during the session, we will take some time in the end for your questions and answers. And then as for the training material, we will share with you the training material and also the recording of the session. Please hang on until the end of the session, where we will share a link where you can register and leave your email address. And there you will also receive the link to the training material. And Laurence, should I share already the link to the data that you will discuss?
We're going to discuss it in the second half of the session, but
Okay.
if people would like to start downloading it now, that's probably a good idea. So let's send it now.
Okay, so please pay attention to the chat already now. I will share with you a link where you can download some of the data that Laurence will discuss with you later on.
Great.
Okay, and then if you could go one slide ahead. Yeah. So I want to make you all aware again of our upcoming webinars. We are more than halfway through already with our webinar series, but we still have some interesting topics coming up. So next week, we will discuss a bit more about digital finance, a very hot topic, I think, now in Egypt. So please don't miss out on that. The webinars will take place on Tuesday and Wednesday in the afternoon. And then we have another webinar on enterprise risk management on the 31st of January. And our very last webinar will also be with you, Laurence. The second webinar on machine learning.
That'll be with my colleague Daddy, who will be presenting on that.
Yeah.
Great, but the two webinars will be working together. So for those that are interested, once we have the data available and ready, then you would want to know how to use it in building machine learning models. So they do go very hand in hand.
Yes, thank you very much. Basil, do you want to mention something about the consultancy packages? This would be the next slide.
Yeah, please, if we can go to the next slide. First, good morning, everyone. Thank you very much for joining us. Just a quick reminder, as we mentioned in a lot of previous webinars, that together with the series of webinars, GIZ offered the opportunity or the possibility for you if you needed more advisory or more support, a package of consultancy packages that you can go to our website, select some of them, and our expert team will be happy to support your institution in this particular topics. As you see on the screen, the 6 topics, our consultancy service that will be tailor design technical assistant or advisory service for your institution if so is needed. More details or details are available on our website. Just feel free, please, to visit the website and register for these consultancy packages if you wish so. Thank you, Zelia. Back to you.
Great.
Yes, thank you very much. That's basically it from our side. In case of any questions, we might interrupt you, Laurence, as I said.
Perfect, no worries.
For everyone who's participating, if you have any problems with, I don't know, the registration link, with the materials, access, and so on, you may reach out to us as always. Okay, and with
Great.
that, I'm handing over to you, Laurence. Thank you.
Brilliant. Thanks very much. Thank you, everybody, for your time. I hope that you'll find this session valuable and interesting. The 5 key topics that I'd like to get through today, or the 5 key sections, are just briefly an introduction, get to know each other a little bit. I'll give you a bit of my background. Then I'm going to go into some of the basics around what we're going to be talking to. So a couple of definitions around machine learning and others. And then we'll get into the bulk of the content before going into a practical exercise that we'll do in Excel, just to give you some indication. So that's the data that Celia was referring to, which we will share with you shortly, that you can download and start just practicing some of the things that we've spoken to. In terms of content, I've focused on this data preparation exercise from a very entry-level starting position, and hopefully we'll take to some of the more sophisticated methodologies. But ultimately, it's really just to give an introduction into how to use data for the purposes of building machine learning model. So, Celia, if we can go onto the first 2 polls, just to get some indication of who's in the room, which institution you're from, and what sort of role you're in, that would be very valuable. Thank you.
So Celia had to leave for another meeting, so I started the poll, but you can see it, right? You can see the poll now? Okay,
thank you very much. Just take a minute or 2.
Yeah, you can just go ahead in the meantime.
And we'll get a little bit. Brilliant. Okay, so we'll get some of the results on the back of those polls shortly, and we can get a bit of a view of who's in the room, what sort of institutions, and what sort of roles. I'm always interested to know the sorts of roles and that people are in. So I think it would be valuable for us to get some of the background on that. A little bit about me. I am South African. You may recognize my accent. I've been told that we have a very distinctive accent in South Africa. I was born in South Africa. I've lived my whole life in South Africa. And you will recognize that some of the brands I've referenced there are very South African in nature. So I do come to this webinar with a South African background, although I do believe that what we're doing in South Africa around data preparation for machine learning is global and relevant and worldwide, and that's obviously why we're quite excited about it. In terms of my specific qualifications, I'm an engineer by profession. I studied at the University of Witwatersrand, which is otherwise known as WITS, qualified in 2001. So I've been applying my industrial engineering background to corporate for quite some time, specifically in financial services. I worked for Nedbank, who had a joint venture at one point with an American company called Capital One. I spent a big part of my career at Discovery. I don't know if everybody in Egypt knows of Discovery, but they're quite an innovative insurance company that is looking to offer wellness programs in conjunction with health and life insurance in across the world. They've got partnerships in all over the world. So my corporate experience is predominantly in financial services. So the way I've applied my engineering degree to financial services is very much in the application of business process and understanding how business process can really enhance the relationships of the way customers engage with these corporate brands. So I was very much in that space, and that led me into a technology background with IT, where I was the interface between the business decisions and the business and the product and the technology team. So my early career, I started in technology, specifically around business process and user applications. I was very involved in designing them, although I didn't actively code until later in my career. Now I'm finding myself doing a lot of work in technology around artificial intelligence and its application in business process. My technology background is not just through this journey that I've got on the screen here. It's actually much goes back quite a lot further. Actually, my mom was a programmer in the 80s when computers were first making things. So I have a very long history in my family has a long history in technology. She was a programmer, busy building. At the time, it was relatively basic applications like we think that we think of today. It was she built an accounting system for a company here in South Africa, and that was kind of my first experience of it. So we had an Apple IIe computer at home when I was growing up that she programmed on. Had no hard drive. You basically had two floppy disks, one on either side, where one would run the operating system and the other would run the program. It was quite an interesting time. So I've really been exposed to technology at a very young age, and as a result, have started applying it in my entrepreneurial journey. I am currently the CEO of a business called Emerge that builds bespoke machine learning solutions for financial services and others. Danny, the person that I referenced, will be giving the second part of the talk, is my co-founder, and he's got the expertise in machine learning. So between the two of us, we've got a kind of engineering and analytics background that brings an opportunity to really find valuable patterns in data. There's another thing that Danny and I both share in common, and I suspect that a lot of the people from Egypt in the call today would also share. So these are 5 things about me, but more importantly, I'm also a Liverpool supporter who obviously has a love for one of your heroes, or your countryman, Mohamed Salah. So that's actually something which I think immediately off the bat we all share in common. So yeah, the current Liverpool team is not, last couple of games haven't been as much as we would have liked, but let's hope for some improvement over time. Okay, great. So
thank you very much, Laurence. Should I share the result of the survey?
That would be great. Thank you.
Okay, very interesting.
Great. Where do I see that? There we go. So there is a lot of people who are in the banking space, a little bit in insurance. Should I bring that onto the screen? Let's just put that up there for everybody to see. We have a lot of banking individuals, more than half, a little bit in other financial services, but that's where the bulk sits. Very few in another industry. And then the other thing which is interesting is not as many technical people as perhaps I would have thought. So there's 26% of you that are in data analytics, but a lot of people in management and product, which is great, because I think what I'm going to be talking through today, or another business role, actually, that's a substantial amount. So what we're going to be talking about today is going to be very kind of starting in the space of data, and I think for business people it will be particularly interesting. For the expert data analytics people in the room, I hope that you still get a lot of value out of it. Great. So then let's go into it. Start a little bit around some of the basics. My intention is to spend about another 45 to 50 minutes on content, and then maybe a little bit longer. Let's see how we go, and then we'll jump into the practical exercise with the data that Celia will share, and leave 15 minutes at the end for questions and answers. As Celia mentioned, I'm very happy for you to interrupt and ask questions in the middle. Celia, please let me know if there's a question. I'm not going to be tracking the chat actively, but if there are questions, please jump in and let me know, and we can stop and deal with it. Often a question in the correct context is simpler for everybody, so please do jump in. Great. So let's start with a very kind of basic definition of artificial intelligence or machine learning. The two terms are often used interchangeably, dependent on who you ask. They have nuance in one what is machine learning, what is artificial intelligence. For purposes of this presentation, I'm going to assume that they're both exactly the same and use them interchangeably. But in essence, it's about finding patterns in data. So the way that and it can be used to apply on all different types of data, all the way from visual data, in the same way as a human being finds patterns in visual data, and I'll give an example in a moment, to auditory data, to words, which are often then used in a word finding exercise or an NLP exercise. But often what we find in financial services is that we have a lot of data that is in a very structured format, a data set in a database that can then enable us to find patterns in that data. So although these pictures are showing a very specific exercise around visual pattern recognition, similar principles are being used to find patterns in structured data. So maybe let's just have a quick look at the two. What you'll see here is there's a line that is drawn on this image to try and differentiate between yellow circles and blue circles. Now, obviously, there are some blue circles within the yellow category, and there are some yellow circles within the blue category. This is a very basic algorithm that has been able to find this. But if a human being was asked to do it, they would do could easily put this line in place. In fact, a human being could probably also do this line. So you'll see here that there are very few. In fact, I don't think there are any. Maybe this little overlap over here, any yellow circles in the blue section, any blue circles in the yellow section. And human beings are very, very good at finding visual patterns in data. We do it all the time. We are, if I were to kind of change the direction of my head or look up a bit, you wouldn't all of a sudden say, oh, there's another person that's sitting in front of me. You are able to identify that I'm the same person because we're very good at identifying those visual patterns and projecting what that person might look like in a different angle, or if they changed their shirt color or they were wearing. Often we do get confused by different contexts. So if the next time you saw me, I was playing a professional football match, you might get a bit confused because the context is off. But we do manage to find a very accurate view of patterns in data. And in fact, what we managed to do is find quite accurate patterns in other types of data as well. So if we were sitting in a room together and somebody new walked into the room at the back of the room, we would all immediately have a gut response to whether or not we believe that person to be trustworthy or not. If they came in waving a gun and saying, everybody on the floor, we'd immediately not trust them because that's an immediate trigger or an indicator. But if they came in and there might be that the person is very tall and somebody in the room has had a bad experience of tall people, or it might be that the person is wearing a blue shirt and you've had a bad experience with people in blue shirts, and subconsciously you make a decision that that person is or isn't trustworthy. And unfortunately, that's a requirement for us to use in the context of the way we live our lives and survival, and that we do have to make these things. And those instincts started a long, long time ago, that human beings were able to do that. Now, that is a gut response that we are trying to train a machine to do when we do machine learning. So it's trying to find the patterns in the structured data to be able to enable humans to be able the machines to find patterns in a similar sort of way to the way we would with our gut response or our learned experience. The difference is that we have to spend a lifetime of learning those experiences, and we can give the machine the various examples, and it can crunch through those examples quite quickly. So that's kind of where the context around machine learning. It really is about finding patterns in data, and the sorts of patterns we might want to find for a corporate financial context are things like who's going to buy a product, which transactions are fraudulent, which customers are likely to default or pay on a loan, who's likely to pay in the collections environment, who's likely to claim in an insurance context, who's likely to cancel on their policy or their account through financial services. So those are the sorts of patterns that we focus on in financial services using structured data. The rest of the exercise is going to predominantly focus, the rest of this webinar is going to focus on structured data. So we'll show you how to try and get some of the value out of that data. it's important to know how to measure the accuracy of a machine learning model. And what I've got here is a Gini coefficient curve, where basically what you're looking for is you're looking to identify, if you rank ordered all of the outputs of a machine learning model from top to bottom, you're looking to get as close to perfection as possible. So what you'll see here is two slightly different gradients. The black line represents a perfect 100% accurate model. So what we're saying here is that if we were to rank order all of the outputs, all of the people that were to buy a product, all the people that were to pay a loan in order, and then all the people that don't, you would end up having a slanted line until you find all of them. At the bottom here, we have the number of customers that are going into the model, and at the top, we have the number of customers that would buy a product or would sell it, or whatever that target variable is. And what you're finding is that a perfect black line goes all the way to the slopes up perfectly till the top, and then it becomes flat at the top. In this particular example, it goes all the way up till the top there. Very few examples of this particular data set that actually did end up having the target variable, and then it goes right to the top. Those in credit might have seen this sort of curve being used before. It's also called the Laurence curve. But what's important to note is that the green line is completely random. If you were to flip a coin on each decision, that would give you this line. People would eventually reach all of the people that have that particular target variable against the whole data set. And what you're aiming to do is you're trying to build a model that will get as close to the black line as possible. And the definition, for those that have heard the term Gini coefficient, is the area between the red line and the green line as a percentage of the area between the black line and the green line. So in this case, it's a Gini coefficient of 73. In this case, it's a Gini coefficient of 89. And just to give you an indication of the step change in accuracy that a machine learning model can offer you, many credit models around the world are sitting at an accuracy of about 20, a Gini coefficient of about a 20 or a 30. A really good one is at 40. Often that's using kind of the regression modeling methodologies that have always been used in credit. Machine learning offers you an opportunity to get 2 or 3 times more accurate than that, and you're aiming to get your predictiveness as close to a Gini coefficient of 100. There are many other ways of measuring accuracy. We just find that this one is quite relevant in financial services because of the way that credit has always looked at Gini coefficients as a measure of accuracy. But the question is, can machine learning do better than humans? So we've spoken to how in visual pattern recognition, we do a really good job of finding patterns in data. In structured data, often the machine does a lot better job than us. We're really good at finding patterns where we've always been things we've used to survive, like visual pattern recognition and gut feel, but we're not so good at looking at 10,000 lines of data, for example, with 41 variables, and then saying, well, let's find the 2% of transactions that are actually fraud. That is not something that human beings do really, really well. And yet we've got machines to be able to do these sorts of things really, really accurately. So what I'm actually going to do is show you a quick AI demo with these data points, 10,000 lines, 41 variables, to give you a bit of a view of how accurate it can be. And it is in Excel, and a lot of what we're going to talk about today is in Excel. There are very much more sophisticated tools that can be used to find patterns in data. A lot of people will be using R and Python and various other tools to build your machine learning data sets, and then to ultimately run the models. But Excel still is a place. And I particularly like this cartoon from Dilbert because it references an engineer having put together the spreadsheet. So that's cool. So in essence, what I'm going to do in the demo, I'm going to go out of PowerPoint in a moment and just show you the actual data sets, is we're going to start with the training data sets, which had 10,000 lines of data, and it was used to build a model. This particular model that we're going to be showing is built in MATLAB, which is also a very common tool for used for building machine learning solutions. Then what we're going to do is we're going to put the input data and run it through the model, and it's going to generate an output, and that output is then going to be compared to what actually happened for that particular set of data. So I'm not going to explain much more on this slide right now before we go on to the demo, because I will show you the actual data sets while we're doing it. So let's go into this data set. What you'll see here is those three data sets that I spoke about before: an actual data set, an input data set, and a training data set. I have opened all of them, but in the meantime, I'm going to run the demo model in the background, and a fifth data set will kick out here called the output data set, like I showed you on the flow chart. So in time, that'll show, but while we're doing that, let me show you the data itself. So this is the training data set. What you will see here is exactly what I showed you before, that there are 41 variables, 41 fields. These have all been transformed from original data points. I'll show you how some of this transformation happened today. This is a unique identifier between 1 and 10,000. We had 10,000 transactions here. And what this 0 means is that it was investigated to determine if it was fraudulent. And the 1 means that it was investigated and determined that it was fraudulent, and a 0 means that it was not. So this is what we call a target variable, where you've got some sort of output that you're trying to get the machine to find more accurately, and then you can run these 41 variables through that data to test whether or not the machine can do a good job around finding the patterns. So I'm going to show you the output of the test now to give you a bit of a view. So here we have, I'm actually going to close this data set. We don't need that anymore. What we do need is we need the input data. So the input data that you'll see there that the output is already there. I will bring it up in a moment. But what we've got here is the input data. So it's the same 41 variables as we had before, except here we've got 100 lines out of it. So we took 9,900 lines out of the training data to be able to train, and we kept 100 out to confirm that the machine was doing what it needed to do. Again, you've got the same ID there. The one major difference between the input file and the training file is that there is no target variable here. So if you have a look here, you don't see any target variable. You only, because the machine is going to find the target variable for us. But we have separated it out and put the target variable into the actual file. So if I go there, and there you will see that it's exactly the same lines of data: 3857, 6559, 4114. It's in exactly the same order, and so will the output file be. So now what I'm going to do is I'm going to, in fact, before I open the output file, I just want to show you that in this particular case, there was only a 2% fraud rate. So out of 100 lines of data, only 2 of those were actually fraud, which is a 2% fraud rate. So what you're trying to do is you're trying to get as much of that 2% differentiated from the other 98%, because then you can avoid wasting time on investigating 98% of the transactions for fraud when you know for sure that they aren't. So if we have a quick look, line item 5655 and line item 7484 are the 2 that are fraud. So 5655 and 7484, 5655, 7484. So now what we're hoping is that in the output file from the machine would be able to find, let me just get that there, the machine would be able to find which one were actually considered to be fraudulent. So this is the score that the machine has come out with. I'm going to take that score and I'm going to copy it into the data set that we have here. And what we're going to do is I'm going to order it from top to bottom. This score will say it is considered to be fraud when it is high, and it is not considered to be fraud when it's not. So not high, so let me just fill that out. Data sort by column C from largest to smallest. And what you'll see is that 7484 and 5655 are both at the top of the list. So in essence, what you've got here is you've got a machine learning model that is 100% accurate. As I mentioned and showed before, not all of them are 100% accurate. But what's also quite exciting is there's a relatively big jump from what is considered to be fraud and what's not considered to be fraud. The other thing that's quite exciting is that you'll find there's a big chunk of them that have got a 0 score. And you'll see there that means that you've got of the 145 of these do not need to be touched at all and can be automatically paid, or the transaction can be allowed to complete without any investigation. Great. So the question, I suppose, is why do we need to do data transformation in the first place? Why can't we just extract data directly from an IT system and allow it to be used in a machine learning model like we had. We've got the 41 variables, we've got the 10,000 lines, we've got a single data set that can be used. Why not just use that? So the reason for that is that is something that my mother obviously was quite understood quite well. The biggest, especially without the kind of computer power that we have today. In essence, what happened is that when we built IT systems, they were not built initially for data usage. For those of you that are in management information systems or business intelligence, you'll know that a lot of the time the data is not in the format you need it for purpose of building all of the dashboards and visual representation. And obviously the same applies for machine learning. So the question is, why? And the reason for that is that we ultimately built machine learning solutions, IT systems, to be very quick. We wanted them to run quickly and to search through large, wide data sets in a very detailed way was quite time consuming. And therefore, we built databases on the back of the IT systems that looked more like this than the data set that I've just showed you, where it was very wide, all in one data set. The reason for that is that if you were looking for a particular response to show on a screen, you needed to quickly go to the table concerned and find the value that you're looking for in that table concerned. And it's much, much quicker to find a table that is got 2 variables in it than a table that's got 100 variables in it. So that was why these entity relationship diagrams and as a result, the database tables were built in a way that there was lots of little tables or lots of narrow tables that had lots of lines in them with the intention of making it quick to use the user application. This obviously isn't good for AI and machine learning. As I showed you before, the ideal data set has got all the data in one data set. So we need to transform the data for the machine to easily look at it and look at all of the examples. In the same way as we look at data when we're building our own gut feel model, we want to understand all of the data in one thing. We want to be able to bring in all of those trigger points when we're looking at a person who's walked into the room. We don't want to kind of say, all right, well, hang on a second, I want to look at clothing now, and quickly look at clothing, and then I want to look at facial expressions, and then I quickly look at facial expressions, and then I want to look at body movement. That just wouldn't work. And as a human, we take in all of that data very quickly. So too, the machine should be able to take in all of the data very, very quickly. Great. So there is another reason, not just data transformations. If we can show the other poll now, that would be great, please.
Yes.
Great. So there is a term in machine learning called feature engineering that some of you may have heard of. It is it's a way of extracting data from it's a way of creating different views of the data for the machine to look at. And I wanted to know if anyone had heard of the term, how many people had heard of the term before we go into it. It will give me some context around how much detail I should go into when explaining what feature engineering is. Great.
Yeah, maybe let's wait another minute until everybody answered the poll. So you can go ahead and then I'll jump in.
Okay, so for those that do know what machine learning is, this might be new to you, but it might not be new to you. For the others, it may be. What I decided to do was start first and foremost with a Wikipedia definition, which we often commonly do. And it gives us a whole lot of jargon and a whole lot of terms. So for me, it wasn't very helpful. And I suppose that's because it is such a general term. I will go into a little bit more detail around what feature engineering is. But if you have a look here, the definition talks to the process of using domain knowledge, so an understanding of the environment, to extract features. And features is another term for dimensions of the data. Using raw data, so we try to use the data at its most raw level, so at its captured level, like we showed in the ERD diagram earlier, and data mining techniques, so various methodologies of extracting data from it. And these features can be used to improve the performance of machine learning algorithms. And I'll explain why it does a good job of helping us get a view of the machine learning algorithms. Feature engineering can be considered as applied machine learning itself. So it's a very important tool to know. And in fact, in our work in machine learning, we spend most of our time actually on the feature engineering and only a little bit of the time on the algorithm building. So this skill is a very powerful skill if you're trying to get value out of machine learning. And we need to go into much more detail than what this Wikipedia definition gives us. Have we got the responses?
Yes. So we got
great.
About 60%, and our audience today is very honest.
Great.
So
very good. Let me bring that across. So 36% of people don't have a clue what it is. 15% have heard the term, and 29% don't know. So we have quite a lot of people, about 8% probably the data analysts in the room, who do know what it is, and some who think they know what it is. But I'm going to try to take a slightly different slant on what feature engineering is in today's presentation, which will hopefully give everybody some new knowledge about it. Okay, so the question is, how does feature engineering work? This gives us a view of why it's important, and I think that this illustration will show you why we want to spend time on it. Does anybody know what that is? You don't have to tell me, just kind of guess on your own. I'm sure you'll have some indication. You've seen something that looks similar to it, but to really know what it is difficult. Does this help? This image, does this give you a little bit more indication of what that is? Perhaps it could give you a little bit more, but again, we're not 100% sure. What about now? Does that help a little bit more? Have some of you got a bit of a view of what that could be? What about now? So now we've seen the whole brown thing, and we've seen a completed, relatively completed view of the circular thing. So now we're getting close. Now we've got a totally different view of the exact same thing, and it's giving us a bit of a hint. And for those of us that have seen this before would know that this particular cork here is slotting into the top of this vessel, but we're still not 100% sure what it is. And if we only got this view without these other views, we might not know exactly what it is. But if we got a view that looked like that, we know that this is a glass bottle in a relatively strange shape. And it has a lid made out of wood or cork, and that is really what this is. But when I went all the way, if I went all the way back to this image, or I went to that image, you would really not have a good understanding of what this individual is, because often what we do is we go into the detail and we don't take a step back to get some perspective. So using the same illustration of this bottle, I want to highlight a couple of points around what makes feature engineering very important. So just going back to that definition from Wikipedia, it is about extracting features. What are those features? They're kind of characteristics. So what are all the descriptors of the data? So can we get a view of texture? So we know that the bottom of that, having seen pictures, having felt the bottom of a bottle before, we know that there's a little bit of a ridged edge there. Just the image gives us an indication of what that is. The color, we know that it's see-through. That helps us. The shape gives us some indication. So already we're getting some indication of just having a look at what those characteristics are. So too in machine learning, we want to give some descriptors to the data set. The ability to use every data point. So in some cases, if we had just been exposed to the bottom of the bottle and not turned it to the side, we wouldn't have seen some of the view of that. But also, we might not have even considered the cork, because from the bottom, you can't see the cork. So you want to look at every data point you have available, and every data set that you have available, as many tables as you can get your hands on to be able to use it. And the ability to extract some of that works. Lots of views of the data of every single data point. So we see multiple views. So again, it's the exact same bottle that we're looking at here. One on the side, one from a top 3D dimension, one from the bottom. If we can twist the data and look at it in multiple different ways, that gives us many more dimensions of the same data set and even the same data point. So one of the examples we'll talk about later is a date field. You bring a date field into your data. Just leaving it as a date field is valuable. one view of the data. But what happens if we wanted to see seasonality? We wanted to see the month. So we've got 5 years worth of data, and maybe there's some seasonality looking at it from a different perspective on everything that's in the 12th month, or everything that's in the 4th month, or everything that's in the 6th month. And so too, there might be some value in the seasonality on a daily basis. You might also want to say, all those that are in a particular month are important. All those that apply on a particular day are important. One of the examples we often use when we talk about machine learning is that we have commonly found that the day of the week that a client applies for a loan is predictive of what type of person they are, and therefore whether or not they will pay. I can't tell you why. I can't tell you why Monday is better than Thursday or Thursday is better than Monday, but it just so happens that in almost every machine learning model we build, day of the week is predictively relevant. Why? Who knows? But it often doesn't, we don't look at the data in that way, and it's great to extract different views of the same data point. And then also it allows us to get perspective of the data. So if we look at the details, like in this one, great. But let's look at also take a step back and see the whole picture. And then in this perspective, we're taking an even different picture. So we don't want to just stay in the detail of the data. We want to also extract out. So feature engineering gives us lots of different things that enable us to see the data in various different ways. So I hope this example has illustrated a little bit about what it means to extract features from the data: text, shape, color, different dimensions, different views, different perspectives, in and out. You want to try and get creative around seeing the data in various different views. So that's some of the basics. What is machine learning? What is AI? How does it work? Why do we transpose the data, etc.? Now I want to go into a little bit around AI data sets and some of the feature engineering examples that we think will be relevant to use in the practical exercise a little later on. So firstly, let's talk about what kind of data you might get in financial services. So whether or not a data set here is sitting in the top right quadrant or the bottom left quadrant is less important for this exercise than just having a look at some of the types of data you might be able to use. Some of them might be internal, so you've got which products does the client have, when do they log into the system, maybe some HR data, so information about the sales agent that was in touch with them or the servicing agent that supported them. You want to know stuff about the process, transactions, some of the application data, but you might also have data from partners. So it's possible to bring devices in, digital behavior and how they behave in that space. Some of these might be considered internal data in your organizations, but some of it might not. What purchases they might have made, if it's a retail company, how they've used their smartphones. Obviously, there's publicly available data. So this is social media data, and crime data might be relevant. So for example, if you want to understand insurance claims and whether or not an insurance claim is fraudulent, crime data in the area involved might help you. Government data, so especially now when we're looking at COVID-related things, COVID data might be relevant. Economic data, we've often found that just using economic data in models is relevant. And then there are purchase data. So you might get web browsing data from Google, or you might get credit bureau data from the credit bureau, or geolocation data is often quite commonly used. So all of these, I put weather data in here from a purchased perspective and not from a public data, because often we find that we have to buy the weather data. But nonetheless, all of this data can be used to find patterns in machine learning. And often what we try to do is start with what's easy to extract, and we use that, but it's possible to use lots of different data sets. What does the ideal data set look like? Like I showed you in the example, you want to have a unique identifier of some sort to describe that line. You want to have a result of some sort, 1 and 0. You can also have a range of output data. I'll show an example of that. You might want to, and then all the other data becomes descriptive to try and help you identify what is a 1 versus what is a 0. And that might be dates or names, so name of a city where the person is, or values. I don't know what this value is. It could be anything. Financial data, so how many Egyptian pounds the person earns or spends or transacts on, etc. So this descriptive data is what we're going to use to find the pattern that is 1 or 0 for this line of data. And we'll talk about how to define that. Okay. I want to spend a little bit of time on a couple of important factors that people often don't consider when building the machine. Some of them are obvious, some of them are less so, but it's important if we're going to start at the beginning to go through this in a bit of detail. So I'm going to go through each of these 6 bullet points one at a time. Let's start with the top one. A machine learning algorithm or an AI algorithm is a mathematical equation, and it is finding patterns using maths. So it is important that all data that we give to the machine is numeric. So there might be some variables that come in a normal numeric form, like financial data or dates. But it might be that those have been converted for some reason to text. So if they've been converted to text, you can't use them as text. You would have to convert them to either a currency or a number or a date of some sort. So that's an important thing to bear in mind when looking at your data. Also, the other thing that might be important to note is that you get a limited option variable like the city, the residential city that I referenced in the previous slide. So that was where it's been captured as a drop-down list. You've got standard data sets, standard list of options, 5, 10, 15 options, whatever they might be. And you then would like to find a view of what the frequency is of each of those items. I'll go into the frequency check in detail, but for those of you that have a little bit of background in Excel, you would potentially know what a pivot table is. It's similar to that, where you're looking at the drop-down list across the top, the individual down the side, and a 1 would indicate that the person is in that category. It's also known as categorization. So whether or not the person does have that category or doesn't have that category will then help you get a different perspective of that data. Also for names of people and cities, if it's not a limited data set of cities, so obviously cities is something that could be hundreds and not just tens, and the name of the actual person could be various lists. You might then want to look at the length of the variable, so longer names, shorter names. You might do a frequency check on the top bunch of those, but also we found first letter to be valuable. So maybe people, or date of birth could be relevant, month that's in there. Again, these are a little bit less commonly used, but we have found them to be valuable at times to really just convert words into numbers. You would do a frequency check on the first letter. So if it starts with an A, it becomes a 1. If it doesn't start with an A, it becomes a 0. And if it starts with a B, it becomes a 1. Again, we'll show some examples later on. But it's important just to remember you have to get your data into a numeric format. Okay, I didn't talk very much about unsupervised learning. Unsupervised learning is where we give the machine no direction of what we want it to find. We don't give it a target variable. We just give it the data and say, find us patterns that we might be able to use. The challenge with unsupervised is that often you don't know what to do with those patterns once you find them, which is why most of the time the solutions we find are valuable are sitting in the target variable space or the supervised data set, and each of those needs to have a target variable. So if we kind of go on to the next slide, which shows the various types of target variables. So in that table that I showed before, it's this gold section is the target variable. If you have a look here, there are generally 2 types of target variables that you would use at a basic level. The first one is a binary. So the target is defined as one of 2 options, normally defined as a 0 or a 1. Where will there be an increase in X? Will there be a likelihood of Y? And you look to have a yes or a no. Will the person pay? Will they buy? Will they cancel? Etc. Etc. Is the transaction fraud or not? And a 1 represents yes, and a 0 represents no. But you can also look to ranges. So target as defined is defined as a range between 2 numbers. Example, how much profit was earned. So if you want to know the profitability for an individual client, you could change these 1s and 0s to be a number between 0 and 1 million. Or it could be between negative 1 million and positive 1 million if you anticipate a loss. So you can also give the machine those ranges, and it allows it to then find those patterns. A couple of tricks we've picked up over the years is that the target variable might already exist in the data. So you need to consider that. So using my profit example, if you put in revenue and costs as descriptive data, then obviously the revenue and costs, which are related directly to the profit, will give you a very highly accurate model because it's interpreting the relationship between profit and loss, and that doesn't really help. So we've got to make sure to remove any data in here that could be a cause and effect on the target variable. May be necessary to calculate the variable. Like I said, you might have to calculate the 1 or 0, or use an interim target value while data is collected. So it may be necessary to collect it or use an interim target variable value while data is collected. So what I mean by that is you may want to identify if somebody responds to a campaign directly. You don't have the campaign data at this point, but you do have a view of overlap of product. So everybody with a transactional account also has a credit. These people have a credit card or these don't. So that will give you a propensity for who is likely to want a credit card. But it's much better to say these are the people I phoned to sell a credit card, and these are the people that actually have a credit card. So you may not have that campaign data to start, and therefore you might have to use an alternative in the meantime. Be careful not to include another variable in the descriptive data that contains the answer. That was the profit and loss one that I spoke about earlier. You can't have any future data. So what does this mean? Let's assume that we're building a model for a sales call to determine who's likely to buy. You could use historical product data, so data that individual had previously, so other products he had in the past, or credit bureau data based on his behavior in the past, or historical campaigns. What you can't include is anything that would not be known at the time that you are trying to predict. So other product usage into the future. Let's assume that this individual has so in this particular campaign, we're looking to see who has a credit card, and in this data we find out that the person has a home loan in a month, buys a home loan a month after that campaign. When you're building the model, you're looking at historical data to try and build and train that model, and it therefore is possible that you might know about the home loan when you are training it. This campaign happens in January. This home loan is bought in February. We're training the model in July. We could look back and say, oh, he's definitely going to buy this credit card because the home loan indicates that. But we want to be careful not to use future data. So these 4 pieces of data set can be used if we're modeling who's likely to buy a product here. This data cannot. And we need to just keep in mind that future data is not included in our descriptive data when we're trying to build a solution. Then it is possible to, I mentioned when we spoke about the ERD diagram that there's lots of different data in lots of different tables. It is possible to then join various data sets together in order to use lots of data from lots of different contexts. So for example, you have a base data set, which is your list of clients. There would be some unique identifier, a client number of some sort, the date that they came in. You then would want to just match that to your descriptive data table. So this is all the data over here that talks about how old they are and where they live and what gender they are, etc. And that you could just join one-to-one on your unique identifier. But you might also have transactional data. So how many times did they use their how many payments did they make in their current account? How many transactions did they do on their credit card? This data then is something which you could then look to join to this as well. The important thing about this is, like we spoke about in the previous slide, you don't want future data. So what you could do is you could join based on the individual's ID and their year and their month to have a data per month to be able to transact then and join it to the time in not only the unique identifier, the individual, but also the time that individual came on and was in the data set. Again, same story with the credit default. You might then have a target variable of a credit default, and you would then join that to the unique identifier for that particular loan. So you can join using your unique identifier, or join using your unique identifier and the time, or any other unique identifier. There might be multiple ones. The loan ID might be in here, and the client ID might be in here. You join the client ID from list of clients to demographic data, but you join the loan ID from here to the credit default. So bear in mind that you can bring lots of data sets together, and how you use them will be important. It is important to make sure your base data set describes the context. So this is an important one that a lot of people don't always consider. there is a time period, right? Is that time period representative, the time period of the data? Is it representative time period of the target variable? So if, for example, we want to look at predicting COVID results, and worldwide we know that in winter there is a spike. I don't know if this is exactly true, but let's assume that winter has a spike and after summer vacation has a spike. If you're just using 1 month's worth of data in the autumn or in the spring, you will not have a good representation of what's going on. And then if you were to run that machine learning model in spring, at the end of summer after vacation, or at the time of winter, you would not get a very predictive solution because you don't have a representative time sample. So what's not ideal is to use a small time period of the results, because that doesn't give you an indication of what's really happening in the seasonality or real time. So to the client base. So you want to use an appropriate random sample of the client base, including good and bad clients. You don't just want to use the top of the top or the bottom of the bottom, because that will give you a biased data set that doesn't represent the whole. Excuse the missing word there. I was supposed to say the whole. So the whole data set needs to be represented, and you want to try and get a random sample of that. So sometimes we have 2-3 million lines of data. You don't need 2-3 million lines of data to build a very good machine learning model. So what you might want to do then is take a sample of that, but make sure that it's a random sample and not that it's the first customers that join or the last customers that join or the best customers or the worst. You want to make sure that it's representative of the client base. And then the third example in this around being representative is representative around that particular solution. So if you're building a sales model, you may want to consider all channels or only the channel that you're trying to model. You might want to use all communication types or only one. So you've got to make sure that the context that you're building your solution in and the data that you're using is representative of what you want to use it for. And this is where your business process becomes quite important. We'll talk a little bit about business process later. How you're going to use that data in the business process is very important for what data you use to train and test your machine learning solution. So a subset of context that is not representative of the training is not good, and vice versa. If you're looking to build a machine learning solution with a small data set, with a small context, don't use the full context to build that solution. The shape of the data is important. So what we mean by this is, I've got two examples here. Imagine that this is where your unique identifier is, this is where your target variable is, and this is where your descriptive data is. Again, here's your unique identifier, here is your target variable, and then this is your descriptive data. So in this one, we might have 1 million lines with 1,000 variables along the top. In this one, we might have 1,000 lines with 5,000 variables along the top. So you've got a very wide data set or a very tall data set. Machine learning needs it needs more examples than it has variables. So even though today we're going to be talking about how to take a single variable and extract it into multiple variables, so date, for example, becomes date plus year plus month plus day of the week, etc. We can multiply it by 5. You want to have a lot of variables along the top, but you don't want to have so many variables along the top that you end up having more variables or a wide data set rather than a narrow data set or a tall data set. So it is better to have more examples than you have fields, which I suppose is somewhat intuitive. When you look at the example that I spoke about before with our visual patterns, we often do have lots more examples of that than we do have variables along the top. So try as best as you can to focus on tall and not on wide. So the green one is better than the orange one. It's not, I haven't made this red to say it's impossible to build a machine learning solution with this. It is possible. It's just not going to be as accurate or as simple as this. So there are methodologies that are necessary to remove some of the non-correlated variables. I'm not going to deal with that today, but if you look up kind of correlation, you can then end up doing that. Great. So those are the key factors that I wanted to mention in that previous slide. Now let's talk a little bit about how we would think about the data in the context of how it's being used. So if we're starting with a machine learning model, there's a business problem we're trying to solve. Things like sales propensity or credit default or propensity to cancel or response to a campaign or probability of being fraud. All of those sorts of things are the business problem you're trying to solve. And there's data that's available to find patterns that will help you solve that problem. So if you have examples of fraudulent cases or examples of good payers or bad payers and a whole lot of information about them at the time, then you will be in that space, right? So the data can help you do that. There's a loop between the business problem and the data. Then we would look to build the AI model. So this would then potentially allow us to then route back into that space, and then we would go through into that loop. But what's also important to consider is the business process. So like we spoke about on the previous slide, the business process defines the context of the data, and it's important to know what the context of that data is. So you are making sure the data represents the context. And then there is the ability to drive an operational intervention. So you would then potentially pick which agent in the call center is most likely to get a sale, and then you would have to include that operational intervention back into your data set. So I'm not going to deal with this in a lot of detail today, but we may get to have a little bit of time when we look at the operational when we look at the data sets later, the practical exercise, to maybe show one or two examples of how we might create an operational intervention based on the data. I think the most important thing to do, though, is to consider these two pieces, the business problem and the business process, because ultimately we want the data to be representing these two things. So it's important to note how those work. So the business problem defines the base data set. What data are we using to be able to identify the patterns we're looking for? And then what is the target variable? So that's what we'd be using the business problem definition for in order to identify here. And then in the business process, this defines the timing of the data that we want to use. Like I mentioned before, if we want to be applying this in winter, we want to make sure that we've got examples of winter. And it also represents the descriptive data that can be used. So how you're going to use the model is important to when considering what data can be considered, because you don't want to be using future data and you don't want to be using data that might give you the answer. So these two things are the place where we would like to spend quite a lot of time before even starting with data, to understand them, to know how we're going to use the business, what the business problem is and what the business process is, and they actually talk to each other. The business problem is to be solved using a business process, and the business process is linked very closely to how we're going to solve the business problem. So consider the business problem, consider the business process when you're looking at the machine learning data set, and then get into your data collation and data transformation. Great. So let's look at a couple of examples of how a data set might work for each of these four financial services use case. So the use cases we're going to deal with are sales, credit, collections, and fraud. And what you'll see here is that the base data set is defined by for sales, it would be the leads that you have tried to contact. So if you tried to contact 5,000 leads last month, that is going to be indicative of what your base data set, and the unique identifier would be the lead number or the lead telephone, the cell phone that was called, or something about that. Then the target is, did it convert to a sale or not? So if it was a sale, you would have a 1 for sale. If it was not a sale, you'd have a 0 for sale. And then you would use all the demographic data you knew about the lead at the time of making that call. So this might be a little bit difficult because it's right up front in the process. We don't have transactions. We might have historical transactions on other products, but we don't on this particular product. So you would probably have a small data set here to be able to identify the propensity for sales, but that's okay. We've found that it's very powerful to build accurate solutions using a very small set of variables, especially if you do good feature engineering. If we're looking at credit, often the problem when building a credit solution is that you can't consider all applications because some of those have already been declined in the past, and we don't know how they're going to perform. So we start by building a solution with all the loans that are involved, so all loans that were approved, and then we have a look and say, well, hang on, using our existing methodology, what did pay and what didn't pay, which loans ended up defaulting and which ones didn't. That becomes your view of default. And then what we look to do is we look to use all data we have at the time of building that solution. Credit application data, which is captured using the loan origination system, or bureau data, or other. Again, you might find that the person's applying for a second loan, and therefore you've got historical performance on other loans that can be used. That's always a very powerful indicator. So there you're looking at whether the individual will pay and not whether or not they will pay this loan. We've got to remember that people behave very differently for different products. So a home loan is dealt with very differently to a term loan or a credit card, but it's still potentially going to have some indication of whether or not the person will pay. Great. Then if we look at the collections one, we're looking at all active loans every month. So you want to see each month whether or not the person is likely to pay and whether or not they'll go into collections or not. Did they pay their installment or not? That's your target variable. You know all data about the loan, the account holder, and the previous payments. So that gives you some indication on previous payers or an indication of future payers, but there might be some information about the loan. There might be some information about the economy that could be indicating. So now with COVID having an impact on the economy globally, there could be some people that are struggling to pay now only because of COVID, even though they would have in other circumstances. And then fraud, you want to look at all your transactions. You want to know whether or not it was identified as fraud or not. And then you also want to look at all data that you have about the account holder, and that transaction. So what day was the transaction? Perhaps you have transactions on a day where there's less going on, or maybe transactions in the middle of the night are considered to be more likely to be fraud or not. Maybe high value transactions or low value transactions. All of those give you an opportunity, and the same applies to insurance. If you're looking at claims, you want to know everything you can about the policyholder. About the policy, about the policyholder, about the claim itself. What are they claiming for? How much is it? What are the circumstances of the claim? And you can get some very accurate predictions on that. And there are many others. Whatever business problem you can dream up, and whatever business case you can dream up, and then whatever business process you can dream up, become very powerful. Okay, let's go into a couple of examples of machine learning. We are a little bit over where I wanted to be at this point, but it's okay. I think we'll be able to deal with the I don't want you to worry. We'll be able to deal with the practical example in a little bit less time, so don't worry about that. I'm going to go through 5 examples of what you might do for feature engineering, and then we can jump into the practical case. So numeric values with no fixed range. So here we're talking about transaction amounts or volumes, whatever might just be a number already. How much money the person earns, how much money they spend, etc., etc. Those are normally going to just be a numeric value, and you would leave them as is. But you might also want to look at some of the historical values as well. What do I mean by that? So let's have a look at this. This is for a unique individual, a policy ABC or account ABC in May of last year, June of last year, July of last year, August of last year, and September of last year. Okay, and we would have a target variable here. It isn't there at the moment, but I just didn't have space on the slide. But we're looking at the value, and the value happens to be 13 in the month of May, 21 in June, 57 in July, 43 in August, and 50 in September. It is always valuable to try and give the machine examples of how that has changed over time. So if you have a look here, this is 43, which is the same client in the previous period. So you'll see that 43 from the previous period, 43 in the current period goes back to 43 in the previous period. And I've done that on all of these. This line shows you how you get that. You end up getting a view right at the end of 1, 2, 3, 4, 5 periods, and how that value happened to be in 5 periods. This is always a very powerful way to give the machine different values of that individual. And you can see then that the line shows, and it repeats itself. I haven't shown them all here because I don't have April and March and February, but you'll get a view of how you would populate these with April, March, and February. Obviously, the beginning data points would have to be considered null values. So you wouldn't be able to give the machine null. So in this particular month, you're only giving it 1 value. In this month, 2 values. In this month, 3 values. In this month, 4 and 5. You don't want to be giving too much history if you don't have that much history. So you don't want to give it, 25 periods if you've only got 4 periods, because there'll be a lot of null data in there which may not be valuable to the machine. But ultimately, you can leave it as is and then include historical data. That becomes a very powerful way to give new perspective on the same data set to the machine. Fixed value fields, so either numeric or not, these are the drop-down lists that I was speaking about before. So year of birth, residential city, etc., etc. So that what you want to do there is when it's numeric, you want to do it as above. So you want to keep it as above. But you also might want to do the frequency calc that I spoke about before, like a pivot table in Excel. So let me show you briefly what that is. In essence, what we're talking about here is this particular individual lives in Giza, this one lives in Cairo, this one in Alexandria, etc. And what you do is you give a variable along the top for each of those outputs. Cairo, you will see here that BCD is in Cairo, CDE is in Cairo, and FGH is in Cairo. There's only one in Giza, only one in Alexandria, and only one in Luxor. You obviously can't give the residential city to the machine because it's not numeric. So you need to extrapolate that to get it to a point where you can give it a 0 or a 1 for it to find patterns. There isn't value in using particular fixed value fields if they are very, very small in representation. If you only have a small data set, Celia, I see you connecting. Do you have a question? No. Okay. If you do, you'll let me know. But if you've got a very small number of people that are there, so for example, you might have a lot of people in Cairo, Giza, and Alexandria, but very small number in Luxor, you would then remove the Luxor column altogether. There's no point putting it in if it's a small volume of people that have it. Only use the high value fixed value fields, and those become powerful. Then dates, we spoke a little bit about dates before. This could be start dates or end dates or transaction dates. What you want to do there is you want to split it out into as many different points as you can, year, month, day, and calculate the difference between dates. You might say this person's been had this account from a start date to an end date. It's 41 days. This person's 51 days. This one's 100 days. Tenure of an individual in the organization is always important when you're starting to look at which agent is engaging. So these dates, you could calculate the differences, but often it's very powerful to look at specifics around year, month, day. So what you would do here is, this is the 20th of January 21. So the month is 1 because that's January. The day is 20. The day of the week happens to be a 4, which is yesterday, which is a Wednesday. So that would be there. You should not use variables that don't repeat commonly. So things like a year, which you're unlikely to see 21 again in the next couple of years, and you're unlikely to have 100 years worth of data. So just leave it out, because then when you start running it into 2022, you won't get that data. So don't include year in there. And if you only have 4 months worth of data, you may not want to include month either, because it doesn't incorporate all the different outputs. And when you start running the 5th month, it's not going to be in your data. So it depends on what data you have available. Try not to bring in data that doesn't repeat frequently enough relative to the data. Text variables. So we've spoken a bit about addresses, names of individuals, where it isn't a fixed list. Here you might want to do length or first letter, or even search for specific words in that piece. You might want to look for the word, if you're looking at qualifications, you might want to look for the word commerce and see whether or not that is important or not. So here we've got again, I'm using the residential city example to be able to illustrate how we might want to use it. So the length of Giza is 4, Cairo 5, and then you've got Alexandria's 10. That might be indicative. And then again, this does feel like it's not going to naturally work, but we have experienced some value in that. I added in Aswan for this particular example to show you how Alexandria and Aswan would both have a 1 under the letter A. Under the letter G, you've only got Giza, you've got C for Cairo, but there might be other cities with a C. So again, these are often the variables we take out when it's too wide, but who knows, they might be valuable. And then finally, a tight range of numeric variables. So you've got the probabilities, you've got regular values. You might want to do a whole lot of mathematical calculations, and this you can really go as wide as you like. A logarithmic conversion or a square roots or any other mathematical formula might end up multiplying variables against each other. So you've got two variables and you want to multiply them against each other. That could be powerful. Again, use your creativity, but also don't allow your data set to get too wide because you may not find out what data is predictive. The most important thing in terms of feature engineering in my mind is get creative, research online, check what other people are doing, and try new things. Who knows? You might find something that others haven't, and that could be very powerful and predictive. Great. So we're a little bit behind on the agenda, but I think that's fine. We can do the practical exercise in half an hour and go longer if there aren't any questions. But in essence, let's jump into the practical exercise. The objective of the practical exercise is for you to play with the data. I've created some fictional data sets that are not representative of any real examples in real life. I've made them completely from scratch, completely fictional. And what I thought would be valuable is to spend 10 minutes or so each individual playing with the data on their side, and then I'll take you through from scratch all four of those data sets, what I might do for some of those data sets to be able to see if we can find some patterns in them. So before we do that, let's kind of jump in and get a view of Excel skill, because you might find that it's going to be important in the context of this, since we are doing this in Excel for now. For those of you that have more sophisticated tools on your machine, go for it, play with those, transform the data in that space. But please don't worry if you don't get completely to a valuable exercise. The most important thing here is really just to consider how you might structure your data and learn from the practical, trying to apply some of the theoretical things we've discussed. So I see that we have put up the next poll, so please do answer that poll. In the meantime, while you're doing that, I'm going to just show everybody what the data says. So reminder, spreadsheets are cool. They can be very valuable, much more powerful that they are. And then obviously engineers are also cool. So you've seen this Dilbert, it's the one I referenced earlier, so I'm not going to reference it again now. Before we bring up the poll results, let me maybe just talk to what the practical exercise is intending and some of the detail around it. So the objective is to set up a data set that can be used to train an AI model that will optimize sales propensity for a client to buy a credit card as part of a call center sales campaign. So that's the objective, to set up a data set. And you will remember we're trying to set up a single data set to give to the machine, but we are starting with four separate data sets. Client data, I've chosen 10,000 to create 10,000 clients. There are 7 variables in the client data. It is January 2014 to December 2020 are the start dates of that particular client. The transactional data, again, a completely random number of 785,364 lines. There will be multiple transactions for each client, so bear that in mind. There are 4 variables for each of them, and the transactional dates are from July 2020 to December 2020. And then the product holding data, so these are other products that particular individual might have. And there are 23,000 product holding pieces approximately, with 3 variables. And then the sales campaign data, in December, this particular call center, this fictional call center, made 2,497 calls to some of those clients there, and we're trying to build a solution to identify and you will see that in that there are some of their outputs. So 1 December 2020, 31 December 2020, those were the time periods for that data. The objective is really to try and get the structure right, to start playing with the data, to see what you might do with the data, and then we'll come back together to work on how we might use it. So it's now 20 past 10. On my side, I think the time is the same in South Africa than it is in Egypt. So if we can come back at 10:30, that would be great. So again, if you need to take a bit of a break now, you can, but have a look at the data. So if we can just show the results of the poll quickly before, that'll be great. There we go. I don't know if the results are coming now.
Can you see the results?
I can't see the results at the moment. Now I can. Okay, so like in most cases, there are some amateurs, but I'm glad to see a whole lot of people who can't live without it and are grandmaster. I'm glad a lot of you think that Excel is cool. So that's kind of where we're at. For those of you that haven't used Excel before, don't worry. It's valuable just to see the data, open the data, experience the data, and we can see more about it. And I don't consider myself a grandmaster. I consider myself somebody who can't live without Excel. So I don't have the skills that some of the people in our audience do, but that's fun. We'll just play with it a bit. We'll use a couple of pivot tables, and we'll use a couple of VLOOKUPs and stuff. If you don't know what that is, don't worry. If you do, that would be great. So if you can play around with these 4 data sets for the next 10 minutes, that would be great. And then I'll start again at 1:30. What I'm going to do is open the data on my side for those that can't access it, so you can also get a bit of a feel for what it will look like, and then we can go from there. Let me just close these, which were from the demo earlier, and I will open the data in a moment for those that have not yet seen it. I'm going to continue sharing my screen during this 10 minutes so that you can have a bit of a view of what that data looks like, and then we'll go from there. I'm going to stop sharing for a moment,
Laurence,
and then we'll come back. Yes.
Laurence, while you're setting up, let me just say a few words.
Sure.
Yeah, please don't forget to take the opportunity to ask questions in the question and answer box. So far, we haven't had any questions, but we are happy to take them either now or later.
Great.
Whenever you feel like asking anything. And as there are also more questions in the chat, yes, we will share the presentation, we will share the recording, we will share the Excel sheets, anything that you need. So don't worry about that. Just please hang on until the end, where we will share a link where you can register your details. Okay, I'm handing back over to you.
Thanks so much. What I'm going to do is start sharing again. I'm going to kind of just show you all of the data as it stands, so you can get a bit of a feel for it for those that haven't managed to download it. But I'm not going to talk and disturb you while you're playing. And then we can get started in some of the pieces there. Let me start sharing again. Great. So very quickly, these are the 4 data sets. This is the client data set, which has got the 7 variables I mentioned. Here is the transactional data set. This is looking at the client and their transaction date, what they spent the money on, and what the fictional value was. And then here we've got the sales campaign data. So this is calls that were made, the results of that call, the agent that made the phone call. And then here we've got some product holding information for each individual. Some of them have got more products, some of them don't have as many products, and you can start playing. While we're busy waiting in the 7 minutes, I'm going to mute myself, but I am going to start doing some of the transformations on my side. If you don't want to see what I'm doing, that's fine. Then just don't look at the screen. But if for those of you that do, that would be great. I am conscious of having lost a little bit of time getting through the theory. So I will start with some of these and show you what I've done after that. So I'm going to mute myself for the next 5 to 6 minutes. Okay, great. I'm going to then carry on. Please do feel free to try and do this afterwards. There's no time limit on it. It's just an illustrative example, but let's kind of jump in. I've done some of the things I want to do, and I'll do some more together with you. But please do jump in if there are any questions at any point. So if the question, I suppose, then is where to start. Let me just close my email so that I don't get any disruptions. Apologies for that. Okay, great. So what we've got here is, the question is, what data set would you start with? Now, if we're having a look at this, let me just kind of go back up here. If we pick that one slide there, if we're having a look at this slide as our starting position, what is the business problem? What is the business process? The business process is a call center, and who's likely to buy it through that call center. So the place to start then is with the business process data, which talks to the sales campaign data. This is the one that we're starting with. And ultimately, we want to find which of the people that were phoned ended up buying the products. So if you have a look here, what I've done is I've created a target variable, which is if the campaign outcome was equal to sale, then make it a 1. And if it was not equal to sale, then make it a 0. The truth is that there's lots of different campaign outcomes referenced here. There's a callback or a did not answer or left a message, but the only one we're really interested in is sale, because that's what's going to give us the view on whether or not the person did or didn't buy. So this is, remembering, obviously, the indicator that came from the call center who made the decision that this was a sale or it wasn't a sale. There may be some mismatches between people who end up buying the product and actually opening an account, a credit card account, and who don't. There could be problems with delivery. There could be a whole lot of different things. For the meantime, we're assuming that the word given to us by that particular agent is correct, and they have actually bought the product. So what you'll see here is that we have a total of 80 sales out of 2,498, about a 3.2% conversion rate, relatively normal in a call center setting, sometimes higher, sometimes lower. But what we've got here is we've got a view of who bought and who didn't buy. The one thing that we are conscious of, though, is that you will see that each individual might have been called more than one time. So 2248 was called in this. Well, the two are there together. I don't know whether or not they were called more than 2 times, but there will be a whole lot of people who have been called a number of times. So what you want to do is you want to have a view in your data set of what was the outcome, the final outcome at the end of the month for every individual person who was called. So of the 10,000 people that were called, 937,000 of them, well, just short of that, we've got 934 of them actually were called, and this is the outcome. So what we've got here now is a base data set of the people that were phoned, 938. You would obviously want to have a much taller data set with more examples. This is just illustrative, and the outcome of what actually happened to them. That I've now copied into another sheet, which I'm going to use as the basis of my future data set. This is the 934. Let's delete the non-data. And then there is our target variable. So now what we have is we have a unique ID and a target variable. What we want to try to do now is add a whole lot of extra data points that will describe the call or the individual being called or the circumstances of that call. So now let's start going to some of the other data sets. You will note, before I move off the sales campaign data, that there is other data here you might want to use. But if you were to be running this model or building this model at the beginning of December to see which of the 10,000 clients, the remaining 9,000 clients we would like to contact, you don't really want to be in a situation where you're using stuff you don't know at the time. If you can control which agent will get which data point, you can include this as a frequency, and then you've got 5 data points that will allow, and then what you would do is run every single scenario through to be able to determine which agent should call that individual. So what you'd end up having would be agent 1, agent 2, agent 3, agent 4, agent 5, and each of them would have been loaded against each potential client that you're running the data through. So when you're running the model, you would have a situation where you would have 5 times the number of data that you want to run through, because you would be considering each agent making the call and what is the propensity of that agent creating a sale. So this is just another tool that you could use to start working out how best to enhance your chances of making a sale, and not just identifying the existing sales in the database. But I don't want to complicate this particular exercise. For those that understood this, great. For those that didn't, not the end of the world. You can ask about it if we've got a bit of time at the end, which is fun. What we'll do though is we'll deal with this a little late. We can deal with this offline if you'd like, but I'm not going to show it in my actual data set. So I'm now done with the campaign data set. I have my unique identifier and I have my target variable. I'm happy. I'm going to close this data set and move on to the descriptive data now. So this is our base file. Let me just save that file, save as. Base file, so that we have it, and I'm going to save it as a CSV. Save. Fun. So now we've got a base file. Now I moved next onto the client demographic data. So what are some of the things that I was looking to do here? I was looking to firstly create features out of the dates. So the first thing, in fact, no. The first thing I actually was trying to do was I wanted to check and see if there was any future data in the data set. So if you have a look here, you've got the campaign started on the 1st of December, and the range of data we've got here is between 2014 and the end of December. So if you have a look here, and I just filter the data to show you, we will have some people who are right at the end. They are in December, and we don't want to be considering clients that joined after the campaign date. Obviously, that does become, this is a bad example because you can't be on my data set of people who would buy the product if you didn't join. But the illustration is really around just making sure that we remove all those that are joining after the potential call to that individual. So that is the first thing that I've done. This particular delete, I'm just going to highlight it in yellow so that we can track everything that we've added. Then the next thing that I did was I went and had a look at a day. So this is the day that the person originally joined with this company. The month is then the month that they joined. The weekday is the weekday that they joined. I've now calculated the difference between today's date. So for those that don't know the now formula, it's now bracket gives you today's date minus that. This particular individual has been on for 2,566 days. And because it's now midday, nearly midday, it will be almost a half a day. I'm going to copy all of those down, and you will see that we've got a whole lot of different pieces that describe the day that they've come in. What I also want to do then is I want to start looking at the rest of these data points. So what I've done here is I've created a pivot table which will give me my frequency for each of the 4 of the other data sets. So initials, which of these people starts with a 1, starts with a B, starts with a C, starts with an I, etc. For city, the interesting thing about city is that the list is very broad. So there's 216 cities that are included in this data set. And you don't have a lot of people in each section. So you probably don't want to include city as a frequency variable. So we'll look to include it in a different type of thing. No more than kind of 60 or 70 people in each. There's one example of 100 there. I think that might be Cairo, et cetera, et cetera. So I'm not going to use the city as a frequency. I'll do it in a different way. So I'm going to delete that particular tab. It's no longer going to be used. Now we've got segments. So which segment are they in? Low income, mid-market, premier, private banking. These could be segments that are relevant for us to use. And then channel. So which channel did they come in? Was it a third-party agent? Was it off some sort of mobile application, branch, call center, or online? And you'll see here that there are reasonable representation of each of these. So we would want to use the segment for here. Some of the other things you might want to use then is you might want to then create a length field for length of city equals len of that, because remember, we're not using the residential city anymore as a frequency. So we would like to just have a look and see how long that variable is. You can also do city underscore a, etc. I'm not going to do that now because we are quite short of time. But in essence, what you could then do, the way to make sure that you bring it in is to use what's called the VLOOKUP in Excel, but there are other join mechanisms in other programs. We look for that client, and we want to bring in whether or not that person was in this particular data set. So it's a 1 all the way through to there. Sorry, that client I'll come back to. And you want to know if they were bought using an agent. So that would be column 2. And we would then populate that in. Let me go find my, it's going to give me an error, but let me just get the actual reference data point as well, which is there. And you'll see that he was not brought in by an agent. Was he brought in 3? Let's just bring the header from that particular channel and bring it into our data set. I'm not obviously going to have time to do all of them, but I will just illustrate how that would be done. So he's not brought in by an app. Was he brought in by a branch? Yes, he was brought in by a branch. So these will obviously then also be 0. And this will also be 0. So now you can see how we're starting to craft a data set that we can then use. And we would also join that data set through to our base data set over here to try and find number 16, what are his data points around each of these things. And you could then copy, join the 2 across from the one to the other. And you would just copy that all the way down. You'll see how some of them end up having ones in different places. So we're now starting to craft out a data set for this, which we could then do as well for initials. We could do for segment. We could do, and then you would end up having, so we'd have another 4 variables for segment, another 1, 2, 3, 4. Sorry, let me just get that. Another 15 variables for initials, and already from just 1, 2, 3, 4, 5, 6, 7 data points, we're sitting on this plus an additional 4 plus an additional 15. We're sitting at a much wider data set, giving us much more examples of looking at the exact same data that enables us to get a view of whether or not that particular individual is likely to buy or not. So this data set would then be joined across to our base data set, which I'm not going to do now, but you would then be able to do that. What I want to show here also is these data. So here in the client data set, we only had one example of each individual. If I were to dedupe this data, just remove duplicates, you would see, and I did it only on client number, you would see that there are no duplicates. There are 10,000 clients here, so they would match across to our base file quite well, 1-to-1. But you don't want to be in a situation where you have an individual there more than once. Because then you would end up having what's called a cross join. Without getting technical, it would end up creating some issues with your data. So what we want to try and do on the other data points is get to a point where we can, let's start with this one. Firstly, we want to check that the data is not before our sales dates. Let me just get the dates, that formula that I had over here. I've closed it, so let me go back here. Give me a second. Just to go back to the product holding. So the date that we looked for was we want 20, 11, 30. That's the date that we would be running this model in reality. And that correlates to 44165. So equals, if that date is greater than 44165, then keep it in, else, sorry, then delete it, else keep it in. And you'll see that there will be some transactions here that we can't consider. So when we do that, 307 transactions out of the 307 product holdings out of the 23,550 that we can't consider. But what we would do next is then create a pivot table here, or a frequency of some sort, to go from there into the product holding. And you would see here the client number goes to the bottom, to the rows, and the product holding goes to the top. We would then filter out anyone who is a 1, because we don't want any future data. So we would take out, let's just go and take out all the zeros. Let's only include the zeros. And you'll see here that for each client, we now have their product holding as at the time that we are running the model. I don't want sum. Give me a second. I want count. And again, it becomes, this individual had 3 transactional accounts for some reason. Maybe they've got one for each of their family members against their name, whatever might be the case. But you'll see here that this becomes a frequency that we can then use. Transactional accounts would be our most prominent, and then there would be a cross-sell from transactional to the others. The other thing that is important to note is whether or not the person already has a credit card at that particular point of making the sale. Now, you may make a decision to try and sell them a second credit card, but you might make the decision that we also put a product at the top here. Or not at the top, we remove credit card because we don't want to sell to people who already have a credit card. We only want to sell to people who have one of the other products. So if they have a credit card, they then come out, and then you would not include them in your product holding file, and you would end up doing that. You might also then want to delete that particular individual completely from your data set when running it. So those are all things you can start doing when you get into a bit more detail. Again, this is just an introduction to it, to feature engineering. Celia, I see that we are at 10 minutes left, and I had allocated 15 minutes for questions at the end. I'm happy to continue with this if there aren't any questions, and you'll just interrupt me if there are.
At the moment, there aren't any questions, but please let me share the link for the attendance right now, because I think
great. So please do interrupt me and tell me where to stop. I'm happy to carry on a little bit with one or two more points that I would like to show for the transactional data. So I'm going to do that for the next few minutes, and if there are questions, please do interrupt me.
Okay, at the moment, no. So feel free to continue.
Great. And then if you have anything you'd like to talk about at the end, we can also just stop for that. So I'm going to do a little bit just on the transactional data to show the creating of a date-based indicator. So if we have a look here, what I spoke about before was that we want to sometimes have a unique ID that is linked to a transactional date. So let's have a quick creation of that. So I want to get the year, and I want to get the month of this particular transaction. So that is equal to YEAR of that, and then equals MONTH of that. And we then create a new unique ID underscore year underscore month, because we want to have a view of each individual in each month. So what we would do is we'd say equals that, and I'm just going to create a formula to create a new unique identifier, and now what you see is we're looking at that client in that month. So what then it allows us to do, if we push this all the way down to big data sets, so it'll take a little bit of time just to finish, you can then start having a look at each client each month and aggregate, for example, the value of the the transactions in that month, or if you do a frequency like we did before and include it in here, you can start looking at the number of insurance transactions for that individual in that month, and it allows you to then really blow out the data set in a big way. But what I just want to illustrate now in the next minute or two is how that would then allow us to join. Sorry, one sec while it finishes. There we go. So now we have a unique ID for each individual year, month. And what you could do then is create a view of that individual for each year and each month. So insert a pivot table. And then what we do is we create a view of the unique identifier by year and by month, and you also then get the ability to have a look at the value of transactions for that year month, which allows you then to join back to our base data set where relevant, to be able to also create a bit of a historical view. So you could then use this data set to start creating what I referenced before, where for this particular individual. Okay, so unfortunately what it's done is it's taken the one before that. So I'm going to just move this to the top. Quickly move to the beginning. And then move this one to the beginning. And then move this one to the beginning. And what you'll see then is that this is the 12th month, but what you've got there is equal to that value. And then this, exactly like I showed in the theory, you can start populating the value of transactions for each previous month. And then again, you've got a whole lot of data points, and you join only the 12s because the 12s are the one that we're looking for. The month of the sale is August. Is December. So that gives us that opportunity. Okay, I see we have run out of time. Sorry, I did spend a little bit more time on the theory, so I'm not going to spend a lot more time on this. Just briefly to go back to show you on the actual presentation, which you will be getting, that I have illustrated a couple of things that I might do with it, what I'd use those variables for. So you might use the client number to join, or you might want to remove before the call date, or look at some of the history, frequency, like we've discussed, length, first letter. You can play around with the data on your own using this this table to go with that. It does give you a little bit of a view of how you might sum the data, how you might join it, how you might aggregate it, etc. Great. So the 15 minutes we had for questions and answers is now down to 5. But before we do close, I would like to just spend 1 minute summarizing and concluding some of our key findings. The first one is that AI is about finding patterns in data as accurately as possible. So we're trying to find those patterns as accurately as you possibly can, and therefore you want to make sure that you transform the data appropriately to be able to do that, which is why feature engineering is a great way to do that. It helps us in a big way to increase the accuracy of an AI model. I have only shared basic feature engineering methods today. There are many others. It really is a trial and error opportunity that can allow for very, very powerful pieces. And obviously with more sophisticated tools and not just spreadsheets, you can do this a lot quicker. You can write code to transform and to data mine. The third point there is that some very basic factors can help enhance the value of your feature engineering. Things we spoke about before around how to calculate your target variables and not using future data, making sure your data is the right shape, not too wide, quite tall. But all of those points we mentioned in the middle section of the presentation. And then the context of your data is very important. I can't stress enough how many times we've seen context of data messing up results or giving us very accurate results, and then we end up realizing, oh, hang on, that doesn't work, and going back and changing the context of the data to represent reality and get a much better outcome. But I think most importantly, get creative and have fun with the data. A lot of this is kind of a newer field. Obviously, AI and data science and the like are not fields that have been around for hundreds of years. They are much more new and there's so much that hasn't been tested or tried. Go have fun, go get creative, test as much as you can to see what is possible. Maybe you'll get some new stuff that no one else has done. You write it up, and then other people start using your stuff. So again, that's there. Have fun, enjoy it, and I hope that you've learned something. For those that have a little bit more of a good understanding of data, I hope it wasn't too basic. For those that have learned something new, I'm very, very excited about that and glad. If you've got any questions, you can also email me. There are no such thing as dumb questions. Maybe. If you do want, you are welcome to reach out to me to ask questions and just check in and see if there's anything you've got in play. Obviously, you can talk to Basel and Celia and the team, but these are my contact details if you'd like to get hold of me, and we can go from there. So thank you very much for your time. I have left 1.5 minutes if there is one question anyone wants, but otherwise, I think we're done. Thanks.
Thank you so much. Thank you, Laurence, for the interesting input and preparing us also for the next session.
Right.
There have been some questions on when we will share the presentation. So we will upload the final presentation within today. I will also include the link for the recording on the last slide. So please check later today on the link, and that you will find the presentation. Other than that, I can just say thank you again, and I hope to see you in the next webinars. And Laurence, thank you very much from joining us from South Africa today.
Thank you.
And I
hope to
see you in one of our next sessions. Okay.
Great.
Thank you.
All the best. Thanks so much for your time. Bye.
Bye-bye.